is doing. That's quite interesting.
Thank you. Okay. Aarti, you can play the video. Voice is not. Coming? Can you hear any voice, Joshua?
No, there's no audio.
This is the visual inspection project for Chukwuere. This unit provides industrial storage solutions to automate the quality inspection process of the upright frame after the powder coating process with computer vision. We need to find uncovered areas, pinholes, blisters, and peel off in a 12 meters long upright frame moving at a speed of 2 meters per second. This is the video of an upright frame moving at a speed of 2 meters per second. Here we can find the defects through normal eye, and hence through computer vision video we can find the defect details automatically. This picture shows the identification of the defects. Product dimension check. This is the visual inspection project for Chukwuere. The storage rack's components should have an assembly tolerance of 0.5 millimeters. We automated the dimension inspection process with our vision system, 0.5 millimeters accuracy. Sequence check. This is the visual inspection project for Chukwuere. To pack their components in a specific sequence, we implemented a vision system to inspect the packaging sequence and to check whether all the components are present or not. Auto stopper in splicing of tire. This project is for Apollo tires. It is the visual inspection process. Here the rubber sleeve roll passes to the production area through the accumulator support. We implemented the vision system to stop when the sleeve roll is about to end or when it gets cut. This video is the splicing process of rubber sleeve by using glycol-reprene rubber PCR and polybutadiene rubber PBR. Label printing. This is a software development project for Chukwuere, an export unit in MEPZ. They have a need to integrate the labels connected with purchase order, marketing requirements, production planning requirements, and dispatch details. Each of the containers which needs to be dispatched will have new label with the purchase order from their legacy software matching products details in separate Excel sheet. We customized a user-friendly software to make labels from mapping their softwares and master data. Container stuffing. This is the visual inspection project for Chukwuere. The process is for traceability and mistake proof of dispatch. We implement OCR to read the label pasted on the package through the camera, which pictures a document for future reference. Vegetable and fruit detection. This is the visual inspection and automation project. The suppliers of fruits and vegetables classifies differently for its clients in establishments or direct users. We automate the segregation process of vegetables and fruits based on their types, ripeness, shelf life by grading using deep learning and computer vision. Shoplifter detection mechanism. This is the visual inspection and surveillance project for Miniso, a Japanese gift shop. They have small-sized products which are unable to be tagged, which prompts shoplifters. We implemented the vision solution to alert the shopkeeper when someone behaves suspiciously. In this image, a person inside red bounding is detected as suspicious. OCR CAMS. This project is for CAMS Finance. They digitize their mutual funds MF documents by typing manually. We automated the process with OCR optical character recognition to recognize the text and stores in the specified fields. These are the only difficulties in alphanumeral similarities which reduce accuracy. The output we got from our algorithm is shown here as a sample. SciR. This is an automation project for SciR. They are providing welding solution for industries. Here we implemented vision-guided robots and cobots to their welding and cutting operation with deep learning. The vision-guided robot will automatically detect the welding area. With a vision system, and the robot will weld it. These are the videos of robot and cobots performing weldings and cutting operation. Fabric picking. This project is for the textile industries. They are currently facing a problem with inconsistency in workers, both in quantity and quality. We are automating the process of pick and place the fabric after screen printing operation with the vision-guided cobots. This was a reference video we received from the client. Bolt picking. This is an automation project for Sunderland fasteners. They are doing threading on the shank by manually pick and place to thread rolling machine. We automated the process with our vision-guided cobot by pick the bolt from bin and place it in the thread rolling machine. This is our vision system setup. This video is we implemented our vision system on their Yashgarba robot. This is a cobot demonstration for pick and place the bolt.
No sound. There is no sound.
Sound will come later.
Okay.
Down hooking. This is an automation project for Godrej Amateur. They now manually pick, place and remove the T-rod on an overhead conveyor in a specific sequence. So, we implemented a vision-guided cobot to complete this process automatically. Panel drying. This is an automation project for Godrej Amateur. The panel hanging from the powder coating overhead conveyor should be dried through the oven. The water droplet formed during this process of quick cooling of the panel coming out from the oven should be removed before the powder coating process. To remove this water droplets by blowing air automatically using cobot application is implemented. Traceability. This is a software development project for textile industries. They are facing a problem of mismatched sizes and materials. We developed a customized software to track the materials, machine involved in the process of t-shirt manufacturing. Kone manual brake. This is the visual inspection project for Kone elevators. They are facing problem of missing dowel pins after the assembly of manual brake, a vital part of the elevator. We detected the missing dowel pins with the computer vision by identifying the gap between the parts. The first picture shows the component with 4 dowel pins, the parts are parallel. The second picture has 1 missing dowel pin, so the parts are parallel. This is our camera setup. Magnet assembly. This project is for Kone. They need an automation for magnet assembly on the rotor. Currently, they are manually picking and placing the magnet. We implemented this automation by using cobot and vision system. This is the magnet assembly process they done manually.
After the video, you will have voice.
Okay.
Depth displacement. This project is also for Kone. Here we are to measure the distance between the hub and the surface of rotor in 10 microns accuracy. We are in the process of identifying the displacement sensors within the accuracy range. Yoke magnet clip flare. This visual inspection project is for Lucas TBS. Inside the yoke, the magnets were locked with flared clips. We can identify whether the clip is flared or not with computer vision and deep learning. This is the yoke having a magnet inside and first picture with flare and second one without flare. 19/20th dear. This visual inspection project for Lucas TVS. They are having a problem of differentiating two components of similar shape but with 1 millimeter difference in diameter. This small difference in the diameter of 19 millimeters or 20 millimeters is measured in a circular area with computer vision for segregating the components. These are the components with different diameter. Here we identify the diameter in pixels. The first and last components are having 20 millimeters diameter. The component in between is having 19 millimeters diameter. Safety monitoring. This is our product. Development here, we detect the people who are working in a construction or manufacturing area wearing PPE or not, for that we use computer vision and deep learning model to detect the PPE. It shows green bounding box on the people when they are wearing a PPE and shows red when they are not wearing any PPE. There is a blue bounding box. It shows the PPE items. By this safety monitoring, we can avoid incidents or accidents in work environments such as manufacturing and construction areas. This image shows the difference between the people with and without PPE. This is the video output. By using our algorithm, we have developed the safety analytics, which shows the compliances, results, analytics, and safety index.
Stop me, Rajan.
Stop. Now you can share the PPT what I've shown. My PowerPoint presentation. Professor Joshua.
Yes, Doc.
See, up to now we have shown you what work we are carrying out in our office. Okay. And the last one, what you have seen is a product development, which is on AI analytics. Okay. And this is the one which we want to commercialize. Okay. And so what I'm going to do is I'll take you through a presentation now and then show you how we have developed and what are the ingredients in this algorithm development.
Sure.
So share the PPT.
Thank you so much.
See, this PDF is termed as AI in safety adherence at workplace. Okay. The artificial intelligence which we are developing is being applied in safety. This is for enhancing workplace safety through the AI applications. So what we are measuring is, see, we are checking through the safety gears that are to be worn by the employees when they are at work. So they have to protect their head, they have to protect their eyes and face, they have to protect their ears, their respiratory, the nose, hand, body, foot, fall protection, legs, hazardous material suits, protective accessories, environment protection, ergonomics, emergency PPEs, and also some kind of boards or displays that needs to be put in the workplace. See, these are the 15 items that are very crucial for any industry where people are at work and their life is at danger if things are not taken care properly. For this, what we have done is we have created an artificial intelligence using the following technologies. One is on the deep learning technology. Second is on the computer vision. Third is on a real-time parallel computing. For deep learning, we have taken YOLO model and we inference it with PyTorch. For computer vision, we are taking SORT algorithm, proprietary Python algorithm, bounding boxes, and confidence levels. Real-time computing is with the CUDA GPU. Okay, so when we are having all these technologies, what do we find? We identify two clauses. One, the person, he or she who's at work, and what they have to wear. See, the person is identified by the person himself, the head of the part of the person, head, the part of the person, which is face, ear, hands, and foot. These are the 6 items we are classifying. And to all these items, what are the PPE, that personal protective equipments that needs to be fixed. For example, glasses. Glasses will go with face. Face mask and medical will go with face. Face guard will go with the face. Earmuffs will go with ear. Gloves will go with hands. Shoes will go with legs. Safety vest with the body. Tools, whatever they carry in their hands. Medical suit, what they wear. Safety suit, what they wear. And then the helmet in their heads. So like this, we may match it so that what they have to take care is being shown. And then comes the algorithm. The algorithm is from the selected YOLO model, we do a real-time object detection. We'll show you, when we make the real-time kind of a demonstration. We have selected 7 S17 PPE dataset for the training of the model and train the model with a custom dataset. We have built the algorithm to see whether the person is with a PPE or not. This is the catch. So if they are with the PPE, they will be shown in one color. If they are not, it will be shown in another color. And with whatever they are wearing, it is the equipment that will also be shown. So the inference of the model with the algorithm is to see that the person is with PPE or not. Used a sort algorithm to track the person by assigning temporary ID and using the ID while he is within the field. Because whoever is in the frame is given a temporary ID so that we identify what they wear and what they haven't worn. Okay. Coming on to the color coding. When the color coding happens, when people are wearing everything, it's green. It's a safer environment. So when you see a box of green, it means they are in a safer environment. Blue is the equipment that they need to wear. If it is visible, it will be shown in blue color. And if they are not wearing any of the PPE safety gears, then it is a violation. So it will be marked in red. We also take into consideration the accuracy and the inference. Inferences put the person in red bounding box warning. So as the person is not working in a safe environment, it includes the PPE as well as the place at which they are supposed to work. So this is where our algorithm will detect and show them. Coming on to the scope, see what we have done is we have created the software. So we can, it's a ready for sale kind of a software. Then we can customize it to the use of the customer. If wherever, whatever safety paraphernalia they're wearing, accordingly we can customize it. We can do the software installation and tethering so that it can be used in that place. Then service and maintenance of software, we can do it. And we will also share with them the upgrades. This is within our scope of WRWS. Whereas partners, like what we expect from Professor Joshua or whoever is trying to captivate the geographic market over there, the systems should be placed in that place so that it's nothing but, it should have a camera and it should have a computer system. But that computer system should have a GPU, graphical programming, programming units, processing units. Sorry. Then integration, we can cover with the software, and then we can have the software installed with user rights, and we can help them with making it display with alert or with the API, application programming interface. Okay, so these things are visible. If you see this picture, where a person is supposed to wear all these PPE, and in the corner there is a security guard who is just sitting down. He doesn't have any kind of a PPE. So the person without any PPE is marked in red, and the person with the PPEs are marked in green. And each of these equipments are highlighted. Like the helmet is highlighted, shoe is highlighted. Like this, we can keep on highlighting. Okay, with this, I stop my narration. We'll take you through the demo. Now you play that.
We created a Python program with Tcooker for GUI. All the display contents were framed within a grid to cover the visual display of the video or live event along with the analytics. Each of the text area that is customized for the specific applications parameter, result, analytics, and index for the video and real-time display. We have controls such as start detection, stop detection, and video upload. Coming to AI analytics for safety, the text area is a compliance parameter which includes helmet, glasses, face guard, glove, and results includes temporary person ID and the PPE like helmet, glove, shoe, etc. In analytics, it shows the total people covered within the frame and within that count of adherence and violations. Finally, the safety index is derived by the number of adherence to the total people within the frame of analytics. Now, we show the video before analytics. The video from construction area before we put in our algorithm. Now we upload the same video in our algorithm. Now you can see the result of the compliance parameter with respect to each individual within the frame of capture. You can also see the analytics. Here the people are in green bounding box because they wear a PPE and it is detected in a blue bounding box. Here the people are in red bounding box because the PPE does not detect it properly. Here the result shows the people with their ID and their PPE like shoes, gloves, helmet. Below that, the analytics shows the adhering and violating number of people. And after that, it shows the safety index percentage. Now we upload an video number 2. This is the video line call for people before going for work. Now we upload the same video in our analytics. Here the people are all in detected in green bounding box because all are wearing and it is detected in our algorithm. Here the people with ID number 88, 90, 92 and 94 are detected as red bounding box because their PP does not detect it. Now we upload an video number 3. This is the video from break operations. Now we upload this video in our analytics. Here all are detected with the green bounding box because all are wearing a PPE. When it shows red bounding box to someone because the PPE does not detect it properly. Here the result shows the people with the ID and their PPE like helmet, shoes, gloves, etc. The analytics shows the total number of people and adhering and violating people. Now we go for video number 4. This is the video from steel shape construction area. Now we put this video in our analytics. Here also the people are directed with our algorithm. Here the people in ID number 199 shows red bounding box because their PP does not detect it in our algorithm. Now we upload a last video. This is also a video from steel shed constructions area. This is before our analytics. Now we put this video in our analytics. This video, the people are in green bounding box because they wear PPE, and the people are in red bounding box does not detect the PPE. Here, these people are with the green bounding box are directed with all PPE, and the people are with the ID number 170, 171, and 174 are directed with no equipment, so they are in a red bounding box. We can also show the live demonstrations if you share your video.
So this video is in.
We created a Python program.
Now, Professor Joshua, we will share your video.
Okay.
You
No,
have shared us a video. We will try to put it in the algorithm and we'll see. Is there people wearing any protective, personal protective equipment?
Yes. I couldn't download the video.
And we are unable to hear you, Joshua.
Okay. Can you hear me? Can you hear me?
Can you?
Yes. Can you hear me?
Yeah. No, yes.
Yes, I'm saying that video. I couldn't be able to download it. So maybe you can the link that I sent to you. I tried downloading it, but it's not working.
Whatever you have shared with us, we'll try to put it in the algorithm and see. How much ever if there is people wearing PPE, then it'll show. If it is not there, it will show as red.
Okay. Wow.
One second. And now you see they are not wearing any gloves or anything, so it shows red
Yes.
boxes. And
Yes, I can see.
let us see if it can detect any human beings.
Okay, I see. Wow. Wow.
See, these people are not wearing any helmets, gloves, and all. So it is in red.
Okay, I can see it's written no equipment. No equipment. Okay.
So that's how even we can show it with our mobile phone also. Through mobile phone also we can scan and we can find out. See, for
Okay,
these
so
people, some are wearing glasses. Glass is a protective
yes.
equipment, so it is showing as glass. Whereas people without any of the glasses, they are marked in red because they don't have any kind of personal protective equipment.
Yes.
So that's how
Okay.
this is very objective in identifying.
Okay, so the system I can see from your compliance, you have a basic requirement. I can see helmet, glasses, blah blah blah, down to the end. Then on your result part, so it's going to analyze the video to show if there are any of those compliance is there with the people, right?
If the compliance, see, for example, in the safety aspect, what we have taken as compliance is helmet, glasses, face guard, gloves, and shoes.
Yes.
See, these are the compliances we have taken. And the results is if that person is wearing or not wearing. Even if one equipment, if they are wearing, it will show as green.
Okay, I see. And then
reason is, see, for example, there'll be some person, who is not supposed to wear because he will be on move. So for him, he may not wear gloves, but helmets and shoes are must in a work area. So he'll be wearing those two. So similarly, like that, you can, as a person who is controlling the safety of that work area, he can take decisions and find out. In the analytics, you see, of the two people, one is adhering and one is violating. So
I see.
So the percentage safety index is 50.
Okay. Wow.
So like this,
So
we can
now,
find out like.
So this result right now is gonna have a printable result, or you have to see it on the screen.
They have to see it on the screen now. If you want to have a print version, we can try to have a print version of it.
Okay.
Of the index.
Wow.
Or what we are trying to give it, put it on a mobile phone and give it, so that the person who is inspecting that place or auditing that place takes corrective action then and there.
Okay. It's quite interesting. It's quite interesting. So it's only looking at the safety of the workers in a work environment. And then,
can you repeat?
No, I mean, like, it's only looking at the safety of the workers within the work environment.
Yes, correct. Not only workers, it includes people who are supervising or executing or even inspecting. Anyone who is in the workplace should wear safety gears.
Okay.
Whether they wear it or not has to be identified and corrected.
It's very interesting. Wow. Wow, that's quite interesting. And then now, my question is it this system, is it a live system, or it can only analyze a recorded video?
No, it can do live analysis. We can show you right away.
Okay.
Yeah, we can apply it in our office and show you. You take the camera on. Wait, we can show you.
Wow.
What we will do is how to show him a live. Oh, okay. See, from the camera, Vishal is going to see one of our colleague, Aarti. She is going to wear her shoes, and whether wearing shoes at workplace is a safety one. So without shoes, another colleague of mine will be standing, and the camera will point out who's with shoes and without shoes.
Okay.
Sure. One second. So you have to unshare yourself. And you have to share your phone.
Okay, I should put on my video, right?
Yeah, please.
Okay.
So now you can see a pop-up of the mobile phone, which Vishal is trying to use it as a camera.
Okay.
So the mobile phone camera is used for identification.
Wow.
In a live instance, we can use any of the cameras installed in the workplace. and you're seeing a picture in picture where this shows the table and furnitures in our office.
Yes.
So now you can share it on our. This is our office, and this is my colleague. You see Aarti with shoes, and she is marked in green. It means she has protected herself.
Okay.
Whereas the person next to him, to her, is Sasta. For him, there is no PPE detected. Can you move Sasta to Aarti, near to Aarti?
Okay.
It shows him in red because he is not even wearing slippers or shoes or anything.
Yes.
So.
Okay. Wow.
See now see red, because if it identifies any PPE, it will show green. Otherwise, it will show red. Go down.
Yes.
Let Aarti shoes. If you see Aarti with shoes, it is red. Whereas for Sasta, it is identifying there is nothing there in his legs. That is, you see a box.
Yes, I see it.
But
yes. Wow.
Shoes or slippers or anything.
Oh wow. So then every environment must be able is customized according to an environment. If you go to in a work environment where these things should be necessary, you need to specify, right? That
Correct.
These are
Yes.
all the protective gears you need to wear. So
yes.
And then when it's not necessary, you need to also specify that this shouldn't be there, that shouldn't be there, that shouldn't be there. Wow.
Correct.
Wow.
So people can, see, this is it will avoid a lot of hindrances or inconsistencies in judgment, and people what they have to wear should have to be wearing it. So it brings a system.
Okay. Wow.
That's how if you see people, clearly it will show what they have to wear, what they haven't worn.
Oh yeah. Wow. it's quite interesting. Definitely. Wow.
No,
Wow.
this we are trying to bring in for other activities also, not only in safety. We want to try it wherever any inspection comes. Those areas also we are trying to include it.
Yeah, I can see you. Wow. Wow, nice one. So but the I what if there is a dashboard where this result is there a dashboard where these results are all stored for reference sake?
Yeah, okay. Maybe we have to develop that. We haven't done a dashboard still. What we are doing is only a live capture of the data and convert it into analytics, so that the person, the safety officer, or the person who is inspecting can quickly identify and correct the situation in the workplace.
Yes.
But as you said, we can find out a dashboard of so much occurrences, so much of adherence, so much of a violation, anything within a time span. Those things can be done.
Exactly, because let's assume the manager deploys it in the office, right? In the workplace, and then leaves for lunch, leaves for anything. And then these people need to put on all these things. And because the manager or the supervisor is not on site, people are now removing all those gears and everything. So when he or she returns, can be able to go through the recordings to see all the compliance and non-compliances, to be able to, so that there can be a consistency in the workplace, so that people don't do anyhow when others are putting it on, others are not putting it on. So there should be a consistency. So it should be able to capture the information, the data, so one can review it. In case something happened, they can know, okay, now let's review the data. Does this thing apply? Was there any breach, any compliance when this thing happened, and so on and so forth? That is quite interesting.
Yeah. Yeah. In the absence of a manager or supervisor also, they should wear. In case if they are not wearing, we have to identify and take corrective action. Correct.
Exactly. Wow. Wow. No, bravo, 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 bravo. Congratulations. This is quite interesting.
Thank you.
Yeah. Wow. It's quite, it's quite
this
interesting.
Is the one which we want to commercialize, Joshua.
Yeah. I think this can also work in different, let's say in a restaurant for monitoring of hygiene, right?
Yes.
Yeah.
It can be done in restaurant. It can be done in hospitals.
Exactly.
It can be done in any operation theater. Wherever personal protective equipments are to be worn. Need not be only in construction or manufacturing. Anywhere, whatever has to be taken for safety, that should be considered.
Exactly. You're right. No. This is very interesting. Oh wow! Congratulations. Congratulations. Thank you. Yeah. No. When I saw there's a video that I saw, I never knew. I was asking myself, okay, I think the video, what you showed me last time, I was asking myself, how does it work? But now I can really understand how it can work and what it can actually do. Wow. Congratulations, you and your team. You guys are
we'll do one thing.
Sorry?
We'll do some more upgrades and then share you.
Sure. And definitely I will always give my inputs.
Yes.
Yeah. I will always continuously give you my inputs. Yes, definitely. Wow, this is very interesting. Wow. Yeah.
Thank you, Prof. Joshua.
Okay, thank you so much for this. Yeah, thank you so much for the demonstration. I really wish you and your team a very good best. Keep pushing. The project is gonna go a long way. Yeah, thank you so much.
Okay.
Okay, bye.